In this video, we're going to talk about angles that are formed when parallel lines are cut by a transversal. So before we start getting into some of those relationships, we need a couple of vocabulary words. So parallel lines are lines that never intersect. And I'm going to put into this diagram little arrows on the lines to indicate that they're parallel. If you see little arrows marked on lines in a diagram, that means parallel. And the two parallel lines in this diagram would be FB and line EC. A transversal is a line that intersects two or more other lines. The transversal in this diagram would be line AD because it intersects the two parallel lines FB and EC. We also need to review some angle types. So complementary angles are two angles that equal 90 degrees when you add them together. Supplementary are two angles that equal to 180 degrees when you add them together. Interior angles, that mean those are angles formed by a transversal and the lines it crosses. Inside the parallel lines. Exterior angles are angles formed by a transversal and the lines it crosses outside of the parallel lines. Alternate are angles formed by a transversal and the lines it crosses on different sides of the transversal. Alternate angles have the same measurement. So we're going to see a bunch of angles that have alternate in the name in a second, and they're all congruent. They all have the same measurement as each other. Corresponding angles are two angles on the same side of the transversal on a different line. We'll see an example of that in a moment. Corresponding angles have the same measurement. They are congruent when we have parallel lines cut by a transversal. Vertical angles are two angles that share a vertex, but not a side. Vertical angles have the same measurement. We know that vertical angles are always congruent. Taking a look at the diagram I have here, and I'm going to just put in that the lines are parallel because that's important here. We're going to name a pair of corresponding angles. So corresponding angles are on the same side of the transversal, but on different lines. I also like to think of them as angles that are in the same position, in the same spot where the parallel line meets the transversal. So notice that there are four spots up here. There's this top right spot. There's this top left spot. There's this bottom right spot. And there's this bottom left spot. And then over here, there's the same thing where this parallel line meets the transversal. There's top right. There's top left. And there is bottom right. And there is bottom left. So each of those angle pairs that are in the same color are corresponding angles because they're in the same spot where the parallel line meets the transversal. So the two brown angles are corresponding angles, the two pink angles are corresponding angles, the two purple angles are corresponding angles, as well as the two green angles. You can also think of it as angles that are on the same side of the transversal, but on a different line in the same spot. You can also think of it as if you take the angle and you translate it down, it should land on its corresponding angle. So one pair of corresponding angles here, I'm going to just do the brown ones, would be angle 1 and angle 5. And I'm going to erase so then I could show you the next type of angle. Vertical angles, we've heard that one before in the past. We know that anytime we have intersecting lines, vertical angles are formed. Anytime we see that letter X, the angles opposite from each other are vertical angles, and they're always congruent. So I see a letter X up here, which creates this pair of vertical angles and this pair of vertical angles. And I see a letter X down here that creates this pair of vertical angles and this pair of vertical angles. So it doesn't matter which pair we use, vertical angles are always congruent to each other. So I'll use angle 5 and angle 8 just to illustrate the vertical angles. And once again, they're always congruent. That doesn't depend on the lines being parallel. They're always congruent vertical angles. Supplementary angles always add to 180 degrees regardless of whether we have parallel lines or not. So any two angles next to each other, like angle 1 and angle 2, will make a straight angle, a straight line when we put them together. So they're supplementary, they add to 180 degrees. Any two angles this way will also add to 180 degrees as well as any two angles going this way. So any two angles next to each other will form a linear pair. They form a straight line, they're supplementary. So I'll use angle 5 and angle 7. They are supplementary angles. Okay. List the two pairs of alternate interior angles. Interior means inside the line, so I just highlighted really badly in purple the lines. So we're looking within the lines. So angle 3, 4, 5, and 6, those are interior angles. Alternate means on different sides of the transversal. So here's the transversal. So for example, angle 3 is on the left of the transversal and angle 6 is on the right. So that would be a pair of alternate interior angles. The other pair of alternate interior angles would be angle 4 and angle 5. And then it says list all of the exterior angles. For exterior angles, we're looking outside of the lines. So once again, if I just highlight the lines really badly, instead of looking within the lines, I'm looking outside. So I'm looking at angle 1, angle 2, angle 7, and angle 8, all of which are outside of the lines. There were a couple of angle relationships that we didn't speak about in this example, so we're going to talk about them in the next couple of examples. So over here, notice that we have two angles, and they're both in the same spots, in the same position where the parallel line meets the transversal. So these are corresponding angles. And notice how they're both on the same side of the transversal, but on different lines. And corresponding angles are congruent. So I'm just going to put that here in parentheses when we have parallel lines. So if one of them is 115 degrees, the other one is going to be 115 degrees as well. In the next example, we have one that we haven't talked about yet. We have inside the line, so we have interior angles. But notice how both of the angles are on the left of the transversal. They're both on the same side of the transversal. So these are what we call same side interior angles. We also have same side exterior angles. And same side interior angles, they start with an S, so the supplementary. Same side interior angles, and I'm going to just write it here in a different color, are supplementary when we have parallel lines cut by a transversal. All the same side starts with S, supplementary. Everything else is congruent, all the other relationships. So if we know that one of the angles is 95 degrees, in order to find the other one, all we have to do is 180 minus 95 degrees, and then we get that the missing angle is 85 degrees. I'm going to put that over here. 180 minus 95 is 85. Then in the next example, the two angles that we have information about are formed by a letter X and they're opposite. So they are vertical angles. And we know that vertical angles are always congruent regardless of whether we have parallel lines or not. So if one of the vertical angles is 58 degrees, the other one is 58 degrees as well. Moving along, the two angles here that we have information about, if I highlight the parallel lines, they're both exterior angles. They're outside of the parallel lines. And if I highlight this transversal over here, that angle is on the left of the transversal, and this angle is on the right of the transversal. So these are on different sides of the transversal. So we call them alternate exterior angles. And alternate exterior angles are congruent when parallel lines are cut by a transversal. Once again, the only ones that are supplementary are the same side ones. So the angle measurement, since they're congruent, would be 76 degrees. Moving along, the two angles that we have are inside the lines. They're within the lines. And if we take a look at the transversal, this angle's to the left and this angle's to the right. So these are alternate interior angles. And alternate interior angles are congruent when parallel lines are cut by a transversal. So if one of the angles is 109 degrees, the other one is 109 degrees as well. In the next example, even though the diagram looks confusing, we have a letter X, and they're opposite on the letter X. So these angles are vertical angles. And we already spoke about how vertical angles are always congruent, regardless of if we have parallel lines or not. So the angles will have the same measurement as each other. Next one. We have exterior angles, and they're on different sides of the transversal. So these are alternate exterior angles, which are congruent when parallel lines are cut by a transversal. So they have the same measurement as each other. The two angles that were given here are inside the parallel lines. And they're on the same side of the transversal. They're both to the right of that transversal I highlighted in purple. So these are same side interior angles. And remember, same side, anything that starts with same side is supplementary. So if I already know that one of the angles is 69 degrees, then I can find the other one by subtracting it from 180 degrees. So I'm going to do 180 minus 69, and I got 111 degrees. So I'm going to write that here, 180 minus 69 equals 111. The next one, both of the angles are on the same side, but they're on different lines. They're in the same spot where each of the parallel lines meets the transversal. So these are corresponding angles, and corresponding angles are congruent when parallel lines are cut by the transversal. So if one of them is a 90-degree angle, that little box indicates a 90-degree angle. Then the other one is congruent. It's a 90-degree angle as well. Both the angles here are inside the lines on different sides of the transversal. So we have alternate interior angles. So they're both the same measurement. They're both congruent. When you are also having alternate interior angles, if you highlight the parallel lines and the transversal, let me do that in a different color, you'll see a letter Z. And inside the corners of the Z are your alternate interior angles. So a big hint that you have alternate interior angles is a letter Z. We have angles on the same side of the transversal. One's in the lines, one's out the line. They're on different lines. They're in the same position. That is corresponding angles, which are congruent. So they're both 121 degrees. We have interior angles inside the lines, and they're both on the same side of the transversal. So we have same side interior angles. And we know that same side interior angles are supplementary. So if I do 180 minus 81, then that should give me the missing measurement. So let me do that. 180 minus 81, and that gives me 99 degrees for the missing angle measurement. Now we're going to do some practice problems. Let me make this a tiny bit bigger over here, as big as I can make it to still be on the screen. If angle 1 is 120 degrees, what is the measurement of angle 2? And you should pause the video to try to answer the questions and then unpause in order to check your answers. Angle 1 and angle 2 form a linear pair. They're supplementary. So 180 minus 120 is 60 degrees for the measurement of angle 2. If angle 5 is 112 degrees, what is the measurement of angle 2? Well, angle 5 and angle 1 are corresponding angles, so they're congruent. And then I know that angle 1 and angle 2 form a linear pair. So if I know what angle 1 is, I can do 180 minus the measurement of angle 1 to figure out what angle 2 needs to be, which here is 68 degrees. If angle 7 is 60 degrees, what is the measurement of angle 2? Well, angle 7 and angle 2 are both exterior angles outside of the lines, and we really should have a parallel symbol on these lines. So I'll add it in because otherwise the relationships that we're using will not hold. And they're alternate exterior angles. So if angle 7 is 60 degrees, angle 2 is also 60 degrees as well, because alternate exterior angles are congruent when parallel lines are cut by a transversal. Moving along, if angle 4 is 135 degrees, what is the measurement of angle 2? Angle 2 and angle 4 are right next to each other. They're supplementary. They form a linear pair. So if I do 180 minus 135, I get 45 degrees for the measurement of angle 2. If angle 6 is 53 degrees, what is the measurement of angle 2? Well, angle 2 and angle 6 are in the same spot, but on different lines. They are corresponding angles. So they're congruent when we have parallel lines cut by a transversal. So whatever one is, so is the other one as well. The next part of the question says that if angle 1 is 104 degrees, what is the measurement of all of the other angles? So angle 1 and angle 2 are supplementary. So if I do 180 minus 104, I get 76 degrees. And there's many different relationships you can use to get the answers to the rest of them. But I see angle 2 and angle 3 are vertical angles, which are always congruent. So angle 3 is 76 degrees. And angle 1 and angle 4 are vertical angles, which are always congruent. So angle 4 is 104 degrees. Now, I'm going to use the interior angles. I know that angle 3 and angle 6 are alternate interior angles. So if angle 3 is 76, angle 6 is congruent because alternate interior angles are congruent when parallel lines are cut by a transversal. Using that same idea of alternate interior angles, angle 4 and angle 5 are alternate interior angles, so they have to have the same measurement. Angle 1 and angle 8 are alternate exterior angles, which are also congruent when parallel lines are cut by a transversal. So if angle 1 is 104 degrees, so is angle 8. And angle 2 and angle 7 are also alternate exterior angles. So angle 7 is congruent to angle 2. They are both 76 degrees. In the next example, we're told that we have parallel lines, AB and CD. So I'm going to mark that in my diagram. And we're told that the measure of angle FYD is 123 degrees. We need to find the measurement of angle AXY. That's this angle right here, angle AXY. So first, I want to get some information closer to angle AXY. So I'm going to use alternate exterior angles, because if I know the 123 degree angle is 123, it's an exterior angle, its alternate exterior angle will be congruent because we do have parallel lines. And then we can use the fact that these two angles next to each other are supplementary. So if we do 180 minus 123 degrees, we get 57 degrees. So the measurement of angle AXY is 57 degrees. Moving on to the next question, we have two parallel roads, Elm Street and Oak Street, and it says find the number of degrees in the acute angle formed by the intersection of Walnut Street and Elm Street. So it's asking for this angle over here. But the two angles that they give to us are alternate interior angles. So since we know we have parallel lines, we can set them equal to each other because alternate interior angles are congruent when parallel lines are cut by a transversal. I'm going to start off by adding 15 to both sides. So I have 2x plus 48 equals to 5x. Then I'm going to subtract 2x from both sides. I have 48 is equal to 3x. And then finally, I'm going to divide by 3, and I get x is equal to 16. Finally, it does say find the number of degrees in the angle, so I'm going to plug back in. So I'm going to do 2 times 16 plus 33. And if I do 2 times 16 plus 33, I get 65 degrees as the angle measurement. In the next example, AB is parallel to CD. We're told that the measure of angle AGH is 4x. So this might be a little deceiving. I'm going to put an arrow. AGH is this angle right over here. And the measure of angle GHD is 3x plus 40. That one looks better. It looks like it's on that angle. What is the measurement of angle X? So, no, this is the letter Z. But the 4x angle and the 3x plus 40 angles are alternate interior angles. So they are congruent when we have parallel lines cut by a transversal. So I'm going to subtract 3x from both sides, and I get x is equal to 40. And this one was just asking for the x value. Here it tells us that line CD is parallel to line EF, and it tells us that the measure of angle DGH is 2x. The measurement of FHB is 5x minus 51. And what we need to do is we need to find the number of degrees in angle BHE. So we're looking for this angle over here. Well, the two angles that they give us expressions for are corresponding angles. And we know that corresponding angles are congruent when we have parallel lines cut by a transversal. So now that I have my equation, I can solve. So I'm going to just, let me erase that. And let me go back to what I was doing. So I'm going to subtract 5x from both sides. And I have negative 3x is equal to negative 51. And then I'm going to divide both sides by negative 3. And I have 17. So 17 is my x value, but it does want the number of degrees in angle BHE. So before I can get that, first I'm going to plug in for one of the corresponding angles, because that I actually have represented with an x. So if I plug in 5 times 17 minus 51, I find that the corresponding angles actually both measure 34 degrees. And then since I know that any two angles next to each other are supplementary, I can do 180 degrees minus 34, and I can get the angle I'm looking for to be 146 degrees. So angle BHE equals 146 degrees, and I should make my answer very clear. The support beams on a bridge intersect in the pattern shown in the accompanying diagram. If AB and CD intersect at point E, find the measure of angle AED. So AED, this is the angle that we're finding the measurement of. Wait, sorry. Oh, it doesn't say find the measure of that. It's giving us the measure of that. It's giving it to us to be 3x plus 30 for AED. And it's telling us the measure of angle CEB is 7x minus 10. And we need to find the x value. Those two angles are vertical angles formed by the letter x, so we can set them equal to each other. No need to know that lines are parallel. Vertical angles are always congruent, which are super nice. We love having vertical angles. I'm going to add 10 to both sides. And then I'm going to divide by 4. And I have x is equal to 10. And it was just asking for the x value, so that's all we need to do here.